Look at the syllabus on the board. We are targeting Section I, Objective 1A. The board's requirement is straightforward. You must be able to perform addition, subtraction, multiplication, and division perfectly across any number base from 2 all the way to 10. Number-based conversions make a lot of candidates nervous. It feels like you are being asked to do math in a foreign language. Examiners know this. They aren't testing advanced calculus here. They are actively exploiting the 10 years of base 10 muscle memory you've built up since primary school. Look at this subtraction problem. When you run out of numbers in a column, your brain has a reflex. You automatically borrow 10 from the column to the left. In base 10, that is correct. In any other base, it is a fatal error. JAMB examiners mathematically pre-calculate this exact reflex. They figure out what answer you will get when you accidentally borrow 10, and they put that wrong answer directly into the multiple choice options. Passing this section requires you to actively unlearn the assumption that numbers always group by tens. To fix this, let's look at it through a simpler lens. Think of a number base like a local Naira Market. A base is simply the mandatory bundle size for a specific economy. Our normal base 10 economy bundles money by tens. You have 10 Naira notes, 100 Naira notes, and 1,000 Naira notes. In a base 5 market, the rules are rigid. Only 1 Naira coins right, 5 Naira notes middle, and 25 Naira bundles left. A 10 Naira note won't be accepted. It doesn't exist here. To hold 10, you must hold 2 distinct 5 Naira notes in the middle column. This gives us our only rule for base subtraction. When you need loose change, you take exactly 1 bundle from the left column, and it breaks apart into exactly your base size. Break a 5 Naira note, you get 5 1 Naira coins. The mechanics of borrowing never change. The only thing that changes is the value of the bundle based on the market you are seoning in. Let's test question 1 from the 2018 UTME. We have a vertical base 5 subtraction problem. The examiner hid variables x and y for us to calculate. Starting at column 1 on the far right, the top number is 3, the bottom is 4. You cannot subtract 4 from 3. Short on change, we must borrow from column 2. We carry over exactly 1 bundle. In a base 5 market, that bundle unpacks into 5. Override your muscle memory right now. Do not write a 10. Add that fresh 5 to the 3 we already have. Our new top value is 8. Now execute the subtraction. 8 minus 4 equals 4. Check the bottom line. The examiner already wrote a 4 there. Our base 5 logic matches the examiner's logic perfectly. Shift to column 2. We borrowed a bundle from this column earlier, so the top number is crossed out. It is now a 3. This gives us our first algebraic equation. 3 minus x equals 4. Can you subtract a positive number from 3 and get 4? No. Short on change again, we borrow from the left. We grab 1 bundle from column 3. Because we're in base 5, that bundle hits column 2 with a value of 5. Add that 5 to our current 3. The new top value is 8. Update the equation. It is now 8 minus x equals 4. 8 minus 4 is 4. We have our first definitive result. The variable x is 4. Let's verify column 3. We borrowed from its original 2, leaving 1. Subtracting 3 is impossible, so we borrow 5 from the far left. 5 plus 1 is 6. 6 minus 3 is 3. This matches the answer line perfectly. Now move to the final leftmost column, column 4, to hunt down y. We borrowed 1 bundle from the original 4, so the top number is now 3. Set up the final equation. 3 minus 1 equals y. 3 minus 1 is 2. Our second variable, y, is 2. We did the hard work. We calculated x as 4 and y as 2. Now, look at the 4 exact multiple choice options the examiner provided for this question on exam day. A rushed student looks down, sees their scratch paper with a 2 and a 4, spots option A, and immediately locks it in. Stop. If you do this, you lose the mark. Look back at the phrasing of the original question. The examiner asked you to find the values of x and y, respectively. Respectively is a strict mathematical command. It means the answer must mirror the exact order of the variables requested. The first number must be x, and the second number must be y. Map our values to that order. X comes first, so 4 is first. Y comes second, so 2 is second. Option A presents the numbers as 2, then 4. That is y, then x. That is the trap. Option C presents them as 4, then 2. That is x, then y. Option C is the undisputed correct answer. Conquering mathematics requires the discipline to micro-step your numbers and respect the base bundle. Securing the actual score requires hypervigilance against the examiner's linguistic traps right at the finish line.